Assalamualaikum and good afternoon. We represent the title of our assignment project from the Group 3 Design Machine Element subject. Our group consists of 4 men, namely as Chong Yu Ching, Muhammad Aziz bin Suhaimi, Muhammad Ikmah Hakim bin Roslin, and me, finally, Muhammad Ibn Amirul bin Rozi. This is our organization chart, which is led by Project Director Ikmal Hakim, followed by Ibn Rozi as a supervisor, Aziz Suhaimi as a teaching engineer, and Chong as a lead designer. As an introduction, we choose the Gearbox after a discussion and getting everyone agreement because this is an excellent opportunity to learn about the Gearbox concept and understand its function. A Gearbox is a mechanical device used to increase the output torque of a motor or to change its own speed. The Gearbox consists of gear, bearing, and shaft. The type of gear in the Gearbox that chosen has bevel gear, spur gear, and helical gear.
Hi, my name is Muhammad Hakim, and I will show you the exploded view of our gearbox. As you can see, this is the exploded view of the gearbox, and you can see the inner side for the parts in the gearbox. Next, this is the bill of materials for our gearbox design. There are a total of 30 different parts in the gearbox. All the parts are listed in the table of bills of materials.
The element and functions. Bevel gear, steel material. The function is connect the shaft whose exit lie at an angle to each other. Helical gear, steel material. The function is to reduce speed and increase torque between turning shafts. Spur gear, steel material. To transfer motion and power from one shaft to another in mechanical setup. Bearing, steel material. Transfers motion and transmits force. Shaft, mild steel material. Rotate and transmit power from a driving device through a machine.
For the FEA analysis of stress, our group members have chosen 5 parts of elements, which is bevel gear, spur gear, helical gear, shaft, and also bearing to undergo the finite element analysis FEA in the SolidWorks software. As displayed, this is the analysis result for von Mises stress. Next is the analysis result of equivalent strain. And the last one is the analysis result for resultant displacement.
When related to motors, pump, or any other types of industrial machinery, gearbox failure can cause a complete machinery breakdown, expensive both in their subsequent repair and lost output. By catching signs of failing parts early, can reduce downtime, save costs, and improve machinery health. These are the possible failures in the gearbox component. The fatigue fracture. Fatigue is more commonly happen in gearing such as tool bending fatigue and surface contact fatigue. Several causes of fatigue failure are poor design of the gear set, incorrect assembly or misalignment of the gears, overload, inverted stress riser or subsurface defect in critical areas, and the use of incorrect material and heat treatment. Impact fracture. Impact fracture is a form where a metal separates into fragments due to stress applied at a temperature below the metal melting points. It can classify either ductile or brittle, depends on the elongation pattern. Gear shafts are the one of the components that commonly having an impact fracture. This is due to the adequate use of specification, misuse or overload under operation and error in the thermal treatment. Where gear usually fail because of normal problem caused by use or maintenance. Over the lifespan of any piece of equipment, component will wear and eventually fail without proper maintenance, upkeep, and replacement. These are most common causes for gear failure in the gearbox: moderate wear and tear, excessive wear and tear, abrasive damage, corrosion, frosting, spalling, pitting, and breakage. And the last one is stress rupture. Stress rupture is referred to the sudden and complete failure of material under stress when there is a constant loading of metals. In general, the four stress rupture to occur is caused by factors such as recrystallization, oxidation, corrosion, or phase change. This possible failure has a few proposed solutions to reduce the damage, such as increased performance by means of residual compression on a thin surface layer. The overall effect is that the probability of quick nucleation and fatigue can be reduced. Next, get a high-quality industrial gearbox maintenance and repair. And finally, controlling the grain size and structure is also an effective method of reducing creep. This is done by increasing the grain size by thermomechanical process, can reduce the creep rate and extend the stress rupture life of metals by lowering the amount grain boundary sliding.
For a conclusion, to summarize, a one-stage helical gear reducer is a gear system that also functions as a motor, which is known as a gearbox electric system. As a team, we develop a better understanding of gear and motor as a result of this study. While learning in this laboratory, we will also learn how to assemble and disassemble the gearbox as a part of the machine element and design subject. We learn the name of the part as well as the function of each part as the result of this. Furthermore, we can determine the best material for each component in a one-stage helical gear reducer. A helical gear set is used to slow down the rotation of high rotational per minute motor. Following the design phase, each component will be conducted to finite element analysis (FEA) to calculate the component stress, strain, and displacement.